Welcome back to notes number 2 for your 6th grade year. We're on pages 5 and 6. At this point, we should all be together in our table of contents here. This is lesson 3-2, estimating products. 9/11/19 is our date, and this is how your composition notebook should look like after we prepped it today in class. So let's go ahead. I'm going to switch over to the next page and we're going to start taking our notes. So here we go. So let's talk about estimating products. So the first thing I want to talk about is a word, product. What does that word mean? Again, one of the things we're really going to be emphasizing this year is vocabulary and having correct vocabulary in mathematics. So product is simply the answer to a multiplication problem. So an answer to a multiplication problem. All right, so let's get into what our meat is for today, and we're going to learn how to do estimation. Now, I'm just going to tell you right now, when I did my notes in my composition notebook, what you're about ready to see, it fit all on one page. It may not fit all on one page in on this screen. So, but again, I had my notes only 2 pages. The left side, which was the blank side, has all of the information I'm going to share with you with 3 examples, and then the right side are the word problems. So, to estimate products of decimals, we're going to round each value. Now, I'll write this a little later on in the notes, but the whole reason why we do this is it is super simple when we're multiplying numbers that have decimals in them. It's super simple to misplace the decimal. So if we do this little estimation first, then we have a ballpark idea where our answer should be. So it's really about helping us get decimal placement in our final actual answer, okay, which we will work on tomorrow. Okay, so number 1, we are going to underline the place value digit to be rounded. To be rounded. So if we're going to round to the nearest 10th, 10, then we're going to underline the digit in the tens column, okay? Now, how do we do rounding? We talked about this a little bit in class today when we were looking at our warm-up. We're going to look to the right of this underlined digit. Okay, and we're going to do a couple things. So, A, if this digit is 4 or less, this digit is 4 or less, the underlined digit stays the same. Now, just to point out, you're probably hearing a bunch of tapping. I'm lucky enough to use the Apple Pen, which, by the way, makes my writing a lot easier to read. But it click, click, click. So some people told me last year they liked it because it was a soothing sound. Some people said it kind of annoyed them, but they got used to it. Okay, it is what it is. So if this digit, the guy that's to the right of the place value that we are going to round, if this digit is 5 or greater, the underlined digit increases by 1. Okay, and C, after rounding, all place value digits to the right of the underlined digit are either 0. Now, this only happens if we have place values that are whole numbers. So if we rounded to the nearest 10, then the 1's digit would become a 0. If we rounded to the nearest 100, then the 10's digit and the 1's digit would be zeros. Okay? So the underlying digits, I'm going to put parentheses, digit or digits, could be 1 or more than 1, are either 0, so these are whole numbers, or are removed. Now, what this means, when we're rounding, the whole point is to get rid of decimals, place values that are to the right of the decimal point. We don't want it at all, okay? We just want to get a good idea about what this problem is going to look like, okay? So we're just going to get a rounded answer. So now that we've done all of this work, guess what? Yup, it is time to multiply. Now multiply. Okay, so how do I know which of the digits to round to? I mean, can I pick any one, or what is it? So we're going to say round each number to its greatest place value. Again, we're going to have one number that's between 1 and 9, and then zeros, and that's it. Make this math super, super simple. All right, let's see. We're going to estimate. Oops, sorry, directions tell us to estimate. First problem, we've got 9.6 times 1.8. So we're going to set up the problem like we're going to multiply. Now, it may look like our numbers, actually I'm going to spread those numbers out a little bit more. It may look like when I'm lining these up or putting these out, I'm lining up decimal points. It just so happens that both of our numbers have 1 digit after the decimal point. So, but that's not the case. You just, last digit lines up with last digit, and you kind of build it out that way. Okay, so first off, where are we going to round to? Well, in both of these, to the nearest whole number. So we're going to look at the digit to the right of the whole number to tell us what to round to. And let's see. According to our rule, 6 is over 5, so we're going to round the whole number up by 1, so that's going to give us a 10. And then 8 is also large enough that it's going to bust up that 1 up to a 2. So when I multiply, I'm going to get an answer that's approximately 20. And I can say that in a sentence if I wanted to. The product, which is the answer to the multiplication problem, is, and here comes a key word, about. When you hear that word, that tells you you're rounding. About 20. Okay? All right, let's try another one. We've got 68.4, and we're going to multiply it by 21.3. 68 and 4/10 times 21 and 3/10. So I'm going to write the problem vertically because that's how we are going to solve it. With this many digits if I was doing the actual math. I'm going to underline the greatest place value, which is the tens for both of them. And then I'm going to look to the digits to the right. Okay, now before, there was no other whole numbers that came after, in number 1, after the numbers we rounded. What made 9 become a 10 is because it got bumped up by 1 value. Okay, so let's see. What do we end up getting approximately? Well, 8 is large enough to bump 6 up to 7, and then the ones place now becomes a 0. So that's what that step C is talking about. 1 is not big enough to bump up to 2, so 21 is now going to round to 20. So again, the ones digit became a 0. So this is so easy to do this math. I just multiply the number pieces, so 7 times 2 is 14, and I count up the zeros, and there are 2 of them. This is a fast way of doing math. So my answer is the product is about 1,400. So what that's telling me is if I do the math, I'm going to end up having a number that has 4 digits in the whole number part. Okay? All right. Let's keep going. We got one more on this page. So we got 42.3 times 3.5. So again, when we rewrite it vertically, I'm just shoving last number under last number. Isn't that funny? All of them were the same. Well, that won't happen on our word problem examples. Okay, so again, greatest place value is the 4 in the 10 spot and the 3 in the 1 spot. Who's going to tell us how we're going to round? Whoops, sorry, not him. Take him away. The 2 in the 1 spot and the 5 in the 10th spot. Okay, so what do we get? Let's see. 2 cannot round up 4, so we get 40. 5 rounds up 3 to 4. So we multiply that, and we get 4 times 4 is 16, and there's 1 0. So we would say the product is about 1,400. I mean, sorry, 160. I was looking at the other answer. So again, these estimates are going to help us make sure our decimal is placed correctly. So when we do the actual math. Estimates help with decimal placement. When doing the actual multiplication of decimals, which again we're going to do tomorrow. Okay? All right, so now we're going to go on and look at the word problems. So I'm going to show you kind of some interesting things you may not have thought of before. And I also am going to point out that some of you have a sheet that on number 4, when it says about how many, it forgets the word Egyptian. So make sure that you add this word if it's missing. So half of you, it's not a problem. The other half, it got obliterated. I apologize for that. Okay? So suppose $1 US dollar is equal to 5.8 Egyptian pounds. About how many Egyptian pounds would you receive for $48? So the question they're asking us is, I see that keyword. Go over here. Do a little highlight action. I see the keyword of about. Okay? And about is very important that we understand that. And then I see the question, how many Egyptian pounds would you receive for $48? So basically what this problem is having me do is my answer needs to be in Egyptian pounds, okay? So I'm going to take this first statement, 1 US dollar is equal to 58 Egyptian pounds. And I'm going to put that answer, I'm going to write it like a fraction. Okay, I know this is kind of bizarre, but I'm going to teach you some good solid math, and we're going to keep doing this until it just hits home with you. So I want the answer to have the final label of Egyptian pounds. So when I write it like a fraction, I'm going to put the label I want on top. And pounds, by the way, is not a measurement. It's a name of a kind of money. Just like in England, they have pounds. Or they used to, now they have euros, I guess. And that would be the same as $1. Now, I have $48.50, and we want to figure out how many Egyptian pounds. So what I'm going to end up doing is I need to put that $48 in such a way that it will take away that $48, or that dollar sign in the denominator. So I'm going to put it here. I know this might sound heavy. Hang with me, guys. This is all going to work out. Now, I want to create two fractions and make this a little easier. So, what I need you guys to notice, dollar sign over dollar sign, they kind of cancel each other out. So I'm left with basically doing this math. 48.50 times 5.8. So now you can actually see what I was talking about earlier with decimal points not lining up. But again, it said about, so we're going to go ahead and round these guys. So we're going to round to the nearest whole number, or the highest whole number for each one of them, highest place value. And what I get is the 8 is big enough to move the 48. Let's go with this color. Nope, sorry. I'm having trouble picking colors. The 8's going to make the 4 go up to a 5, so this is going to be about 50. And then the 8 is going to make the 5 round up to about 6. So if I multiply those, 6 times 5 is 30, and there's an extra dollar, I see 300. So my answer would be, there are about 300 Egyptian pounds in $48.50. Okay? All right. Next problem. Earth is rotating around the sun about 18.6 miles per second. About how many miles does it travel in 48 seconds? So again, in the question part, we see about. And then I'm going to circle up what they want me, or underline it, what they want me to solve for. And this is going to be miles. Okay? So I see some other pieces of information. So in the first one, it talks about the Earth is rotating around the sun about 18.6 miles, and I put that on top because I know my answer needs to end with miles, and then it's per 1 second. When it says per second, it's only one of them. Okay. Now, in order to get rid of the seconds, remember the last number is 4.8 seconds, so we're going to go ahead and put that up at the top. And because I want to do multiplication, because that's how I'm going to get seconds canceling with seconds, when I have the same thing over itself, it equals 1. So I'm going to make that a fraction like that. And then seconds cancels with seconds. So really what your problem becomes, I'm going to do it a little bit differently over here, is 18.6, and we're going to multiply by 4.8. Okay, and so what we're going to do is estimate again, and we're going to round to the nearest 10 on the 18.6 and the nearest 1 with the 4.8. And the guys in charge of what we're going to get the ones digit and the tenths digit, just like in the last problem, okay? So I'm going to get an approximate answer. And 8 is big enough to round the 1 up to a 2, so I get about 20. And the 8 is big enough to round the 4 up to 5. So I get 20 times 5 is 100. So my conclusion would be the Earth travels about 100 miles, and abbreviate miles to mi, around the sun in 4.8 seconds. Okay. Now, the last one. The average walking speed of a person is 4.8 kilometers per hour. Estimate the number of kilometers you could walk in 3 hours. So again, did you hear that word about? No, because what we heard was the word estimate. It actually told us what to do, right? So what I notice is that we've got our answer needs to be in kilometers. Estimate the number of kilometers you could walk in 3 hours. So the first statement is the one we're going to write with kilometers on top. So average walking speed of a person is 4.8 kilometers per hour. So that's 1. And we're going to end up multiplying by the last number they gave us, which was the 3 hours. Now we want to turn this into a fraction, so we're just going to give it a denominator of 1. Now notice hours and hours, bye-bye. So my problem is now kind of simple. 4.8, and I'm going to multiply by 3. So guess what? We only have one thing to round because we're not going to round 3. 3 is rounded enough. It's a whole number. There's no decimal parts to it, so we're good. So the only guy we need to contend with is the 4. And what's going to determine what happens to him is the 8 to the right. So 8 is large enough that it's going to round the 4 up to a 5. And the 3 stays 3. So we get 15. And so our conclusion is you could walk about 15 kilometers in 3 hours. And there you have it. All right, good luck with this, and we'll talk about it tomorrow in class. All right, good night, guys.